We showed the performance of our learning from demonstrations algorithm in a variety of tasks. The first task we consider is a valve rotation task, where we rotate a valve off-center as shown in these demonstrations. When we run our algorithm at a variety of positions around the valve with a single neural network policy, we see that the policy generalizes and is able to turn the valve in multiple positions by showing different behavior at each of the positions. We compare the performance of our algorithm to a number of other baselines. For the first baseline, we hand design an open loop controller which works at one position, but when the same controller is applied at another position, it doesn't work because it has no notion of generalization and is open loop. In our second baseline, we trained a controller using reinforcement learning to copy one demonstration at one position, but when the same controller is applied to another position, it does not generalize well. As a metric for comparison, we compare against an oracle where the demonstrations to be learned at each position are already hand assigned, and this is an upper bound for our method which automatically learns to choose which demonstrations to copy. In our second task, we have the stationary hand move only the yellow bead of the abacus as shown in these demonstrations. We see that our learning from demonstrations algorithm is able to learn very distinctly different behavior using different fingers at different positions to succeed from a variety of positions, only moving the yellow bead. When compared to a hand-designed open loop policy, which in our case is only moving the ring finger, we see that it succeeds in this position 1. However, the same behavior, because it's open loop, does not actually succeed in another position where it has to move a different finger. When comparing against the baseline of a single demonstration, we train a controller to imitate demonstration at position 1. But we see that because this has no notion of generalization, this doesn't actually work for other positions like position 3. We see again that an oracle, which already has demonstrations assigned to various controllers, is able to do as well as our algorithm, which also is able to use the right fingers to push the right beats. In this task, we aim to show that we can use reinforcement learning to grasp a bottle, copying a demonstration as indicated. We see that the hand-designed open-loop controller is able to get a firm grasp on the bottle and pick it up as shown here. However, we also see that our method is able to do just as well in grasping the bottle firmly and picking it up to a given height.